Get him!
Quick business call, sorry.
This is the part where you're quiet and doing math, right, Kelser? Come on now. We're like 6 weeks in. You don't know how this works. It's 3 dozen. Oh, we still got 5 over there. It depends on the year. I've had years where I get 6 or 7 dozen and they're gone before lunch. Yeah. Game Club's Breakfast Empire. Come on now, quiet down, do your own thing. Not your neighbor, you. Because I haven't charged those for 4 weeks. Those things last forever. If someone comes in or texts me or reminds me or something after 3:30, then I'll plug them in over the weekend. Okay. Guess and check with calculator if you need to. Use multiplication chart if you need to. I would pay extra attention to that factoring decision tree that we were talking about yesterday. Because it tells you how to do this. You just answer the questions yes or no. Also, big props to any of you who your folks came for conferences. Even better if you came with them. It was a long night, but a good night. I had 19 amazing conversations. I didn't have a single parent walk out of the room mad. Everyone was smiling, laughing, or at least relieved. Because even if things are going bad, we have a plan. So if you and or your folks came for conferences, it was a good night. Long and exhausting. I feel like I'm about dead and I'm only held up by caffeine and pseudoephedrine right now, but you do what you gotta do, right? I'm only at 10% health. Hit me with that stim pack. Turn your phones off before you come to school. It was Gollum. Oh, no. No, it was me. Okay, we should have been done long before this, so I'm going to ask the question. Do you know your perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on? Particularly the second one should have taken you all of 2 seconds. If you can answer that question, yes. Do you know your perfect squares through 20? Kind of important there, hey. I suppose I should do an attendance thing, right? There we go. Anyone still rolling? Give you a minute to win it. Get her done, dude. Get her done. Told you I had a kid a couple of years ago who left a giant bag of like frozen pancakes in my fridge. He'd have pancakes every day for pre-calc. Go for it. I don't care. Are you learning something? That's all that matters. If I'm going to factor completely, the first step on the factor train is find a GCF. And I see these two happen to have a 2 in common and an x. So I'm left with a 6x squared minus 11x plus 4. I go to the next stop on the factor train, and I ask, are a and c both perfect squares? 6 isn't. So go to the next stop on the factor train. Is a equal to 1? No. Go to the next stop on the factor train. Oh, it's the AC method. So a times c is 24. What times what makes 24 but still adds up to my b value of negative 11? So now, don't forget your kid brother at Burger King. Okay, we're going to just work here, but remember that's still part of this. 6x squared minus 8x minus 3x plus 4. Factor each half. Say these got a 2x in common, leaving a 3x minus 4. These got a negative 1 in common, leaving 3x minus 4. Take out the binomial factor they have in common, 3x minus 4, and I'm left with a 2x minus 1. Don't forget your kid brother at Burger King. Okay. Yeah? If they're both negated, then it will come out the same. You're still good, bud. Okay? Just like if you swap the order on them, right? It won't matter. The second one. Now we see who's paying attention. Is there a greatest common factor? Nope. Are a and c perfect squares? Yes. Is there a middle term? No. That means it's a plus minus pair special form of the square roots of these. 14x, 19. Done. Okay? If you know your perfect squares, this doesn't take long. So, I'm going to say 2 for this one. Did you get the plus minus pair with the correct numbers. Now I say the plus minus pair with the correct numbers because someone in here might have tried to say 14x minus 19 the quantity squared, like kind of mixing up the two special forms. Did you factor out the greatest common factor and write it in at the end? Did you get the correct factors? Did you have the work to back it up? Because somewhere along the way, if you goofed any of this process, it's going to change these. Now I say that with the catch that, is there anyone in here who got to blue and then is able to mental mojo it down to orange? Is there anyone who could? Go straight from blue to, or red? Okay. So I'm not going to penalize someone who can actually do that. Okay, so 3 for the first one, 2 for the second one. Yo.
What if I did it this way?
What if I did it this way? Oh. Okay. So who did not take the greatest common factor out until the end? Like, you tried AC method here. Okay, 1, if you're doing that AC method, did you break it directly into two binomials with something x squared, something x? Not x and x. Not x squared, but x squared and x. Because that's how you get x cubed. If you did, yes, you're good. You still have to take the 2x out at the end, but you're good. You get what I'm saying? Like, the two binomials, did you write them as x squared and x? Because that's the only way you make a 12x cubed. So if you had done AC method, understanding that one binomial will have x squared and the other will have x to the first, sure, that's a different way to go there. I'm cool with it. Okay. All right. I had 4 questions last night. One of them was math. The other 3 were people who are relying on Remind for their assignments. Y'all, I told you. Website. Website has Planbook embedded in it. Right above that is the join code for Planbook. It's there. Okay, it's not always accurate immediately after class. Sometimes I don't update it until later, but Planbook, it's a thing. Okay, there will be days where I just plain forget to do Remind at all because life. Yesterday, a lot of life happened. I yacked at people for 8 hours straight. I hurt. Okay, if y'all know where the assignment is, go to Planbook. But do we have any mathematical questions? Yes, ma'am.
Number 69.
Immediately hear someone in the room. Nice. There we go. If I take a negative out of there, I got a difference of squares. Just because it's a fraction doesn't mean it's not a perfect square. The square root of a fraction is a fraction of square roots. The square root of 1/16 is the square root of 1 over the square root of 16. It's a difference of squares. Difference of squares has the form plus minus the same binomial. Square root of this is 1/4 s. Square root of this is 1. Don't forget your kid brother Burger King. And we say that because in the year 2002 of our Lord and Savior, Aaron Nash left his brother at Burger King in Grand Forks, North Dakota, 18 miles away from his house, and didn't realize it until he pulled into the driveway. When you factor something out, just remember to bring it all the way to the end. Yes, ma'am.
What do we do if x doesn't equal 1 and there's no middle term? Would we use a similar way?
A doesn't equal 1, there's no middle term. That'd be just like our daily quiz. Difference of squares. Like which one?
Number 36.
36. Here's a middle term.
Oh, I see. Never mind.
Okay, now let's say you had, now this difference of squares thing, it works even if they're not perfect squares. Remember there was a problem yesterday? I said, done for now. Go find that. Wait, no, not that. Algebra 2, shared folder. There it is. Problem number 2, got it to A. Okay. Now when we first did this, we factored out a 7, n squared minus 3. And I said that's enough for now. Now, what's the middle term? Like A, B, C, right? A is 1, C is negative 3. What's B? 0. Okay. Now, if that was n squared minus 36, you would all be fine, right? I'd say factors of negative 36 add up to 0 in the middle. X plus 6, x minus 6. Difference of squares, that's our special form. But if I ask you what factors of negative 3 add up to, or what, 0, it doesn't work until you remember squares. It's just the square root of that thing, right? Just like the square root of 36 was 6. The square root of 3 is just the square root of 3. And that's it. So you ask, how do I do this if I have something really dumb like 48 n squared minus 71? I can still factor this as difference of squares. It's just butt ugly. This is going to be the square root of 48, which we have to know how to reduce, right? 4 root of 3n minus square root of 71. 4 root of 3n plus square root of 71. Okay? I can still use difference of squares on things that aren't perfect squares. Now, I'm seeing bug eyes that tells me I know what our Tuesday lesson's going to be. Y'all remember how to do square roots? Oh, hell. Okay, so on Tuesday, we are not going to go on to 4.6. We're going to do like 4.5999999 before doing 4.6. Because we got to know how to simplify radicals before we can go any further. You learned how to do this in Algebra 1. And you should have beat it to death in geometry because all of the formulas involve something squares and square roots. So you should have been writing your answers in simplified radical form, not in decimals. This is why I hammer on kids to write it the correct way instead of go to decimal town. Because otherwise they come up to Algebra 2 and we have to review Algebra 1 to even get to the next lesson. Like, seriously. Whoever can do that without your calculator just telling you who's got the cheater one. Bad Bailey. Bad. Bad. No, put that back in there. Okay. No. No. Go. I dare you. First one to get it. Donut. Oh, well, that was quick. I didn't expect someone to get it that fast. Okay. Yay. Good. Someone knows. Yeah. Right? Because 36 is the largest perfect square that goes into 72.
Oh, I remember how to do that.
Or the old way, this is truly ancient magic. And then 1, 2, 3 twos. 1, 2. And every time you have a pair in radical jail, they can rush the guard and one gets out alive. One rushes and gets out alive. So 6 root of 2. Okay? So maybe we got to take a day on Tuesday to hammer that pretty good before we move on to complete the square, in which starting... Wait, so we're going to do that Tuesday. So wait, we did a quiz on Thursday. Fubar Day Monday. Tuesday, Wednesday, Thursday, Friday. Tuesday, so we'll have a quiz on Wednesday. From next Thursday to the rest of eternity, you write your answers in simple radical form. You do not go to decimal town in my house. Okay? So we're going to take a day off of book stuff on Tuesday, and we are going to make sure we understand how to simplify radicals because it's a prerequisite to be in the room. You need to know how to do that. Okay? All right, good to know. Back to that, did we have homework questions? All right. Answer the question. Argue with your neighbors. Figure it out. You know stuff about quadratics now. Figure it out. You know, I can't stand Mexican food, but damn, that smells good.
Right?
That smells good. It's not even asking for the equation. It's just asking what is C. Oh yeah, no. Yesterday was just a giant crap stack. I didn't get to any of this. Here.
Yeah. Oh, look, it might be cool.
Yeah, they got kind of different security gear and this morning I got so confused when my calculator gave me the like times 10 thing because of
Oh, scientific. Yep.
And then you do X. When you do X, Y.
actual symmetry.
Is it like A squared plus B squared equals C squared type of thing?
Maybe. I may be told. That seems right.
Hearing a lot of good conversation. Puzzle it out. I want like this on a T-shirt. Just.
How do I get to the part with the times?
These designs and really grabs like that. Not right.
Add.
Oh wait.
Yes. It's extremely flammable. So what you should do
And every warning on everything that we've ever seen, there's a lawsuit that made it.
And yourself.
It's literally 6.4.
Because maybe they're
You're right, bro. You just add to the same length on each side.
So we're saying, bro, it's in the middle.
There we go. Was waiting for it. All right. Who got 25.92? Good, because that's the wrong part. That's the y part of the coordinate. Who got 12.8? Who got 14.4?
times that by 2, that's what I got.
Who got 20.8? There you go. 20.8. Because remember that a parabola has an axis of symmetry. If point A is 14.4 to the left, then point C is going to be 14.4 to the right of the vertex. So you have to take 6.4 minus 8, or minus negative 8, to find the distance. And then you take that distance and add it on to 6.4. If from here to here is 14.4, then I need to go another 14.4 from 6.4, getting 20.8. Or, if you remember old school geometry, midpoint formula. Remember those? The midpoint formula, if you already know that the y is going to be 0, then you just deal with the x portion of it. You know that negative 8 plus x sub 2 over 2 is going to equal the midpoint 6.4. Cross multiply, add 8. If you remembered the midpoint formula. But it sounds like none of us remember it other than, geometry flashbacks. So, now this is just a general application of A and C are both called x-intercepts. They're x-intercepts because they, well, intercept the x-axis. But every coordinate on the x-axis is something, comma, 0. So every one of the x-intercepts is called a 0 of the function because you set it equal to 0 and solve, which is what we're doing today. If I got a quadratic equation and I want to solve it, I set it equal to 0, and I will get the solutions. So we know that the x-intercepts are when it equals 0, so I call them zeros. The zeros are the solutions to the equation. So that means, you all remember these maybe from geometry, they're called biconditionals. Biconditional means it's true both ways. Okay? An x-intercept is a 0, is a solution, is an x-intercept, is a solution, is a 0, is an x-intercept, is a solution. They're all different, they're all talking about different things. Like, the meaning is different, but they're all talking about the same object. It's like this. What is this? What else is it? This object right here, what is it? A finger. What else is it? Come on, y'all in biology. Oh, digit. Phalanges. Okay? It's got all of these different names, but it's still the same thing. Same deal here. These all refer to it in a different context, but they're talking about the same location. All right, here we go. If I want to find the solutions, step number 1, get everyone on this side of the bus. I have to set it equal to 0. So, I will have 5x squared. I'll add 2x. I'll subtract 2 equals 0. Y'all cool with that so far? I have everything on one side, and it's now a quadratic in standard form. What did we do yesterday? Factor. Factor the quadratic. Well, ask yourself all the questions. Is there a greatest common factor? Are A and C both perfect squares? No. Is A equal to 1? So, AC method it is. Step number 1, I take A times C, and I get 60. What times what makes 60, but adds up to make my middle term 32? Just 30 and 2. So I'll use that to split B. 5x squared plus 30x plus 2x plus 12. See, before, someone was the third wheel and it was awkward. Now, double date. You okay? So I will cut it in half and ask, what do we have in common? And an x, leaving a x plus 6. Well, what do we have in common?
2.
Leaving a x plus 6. Take out what they have in common now. Both of these have a binomial, x plus 6, and 5x plus 2 is left over. Now keep in mind, all the way along the way here, this was equal to 0. How does that help me on them individually? Because what this is effectively saying, if I say A times B equals 0, one of them got to be 0, right? I don't take like -3 times 3 and that's 0. The only way you get something times something to make 0 is if one of them is 0. True. Okay. So I'm going to set x plus 6 equal to 0 and get x is -6. I'm going to set 5x plus 2 equal to 0, getting 5x is -2, getting x is -2/5. Those are the answers. I set it equal to 0. I found the things that will make it equal 0. Therefore, these things are the zeros of the function, which are also called solutions, which are also called the x-intercepts. If I were to graph this parabola, I would have an x-intercept at -6 and at -2/5. So, factor it, set the factor is equal to 0. Yes, ma'am?
Is it a brownie point since the parabola is supposed to go the other way?
No, it's a positive parabola.
Oh yeah, okay, never mind.
All of my caffeine kicked in, so you guys don't get first hour's deal. It was bad, so I just walked up there at the beginning of class, threw 3 down, and said, "Leave me alone." Yeah, they are. All right, your turn. No, it's just the caffeine kicked in, so I'm not going to suck as bad. Get it? It's like last night conferences, I just survived off of decongestion meds and caffeine. Got home and fell asleep standing up in the shower. Were you just so toast? Yeah. It happens. Okay. Remember, check it out with your neighbors. Even if your factors are in a different order, that's okay. Multiplication's commutative.
Because you add an x to negative 4.
Okay, I spent a lot of last night talking to parents about different ways that kids learn. I want to point out in this room just now, I saw we got Callister and Matthias over here are arguing with each other. They both learn socially. I hear Caden and James just like muttering to themselves. They went in the tank. But as soon as you hear yourself saying the numbers, doesn't it make it happen? If you have to sit there and be quiet, it doesn't work as well. But if I'm able to talk to myself, it works. Everyone has their own jam. That's true when it comes to a quiz as well. If you work better when you're talking to yourself, maybe you should just come in during Spartan time to do your quiz instead so you can just talk to yourself and not disrupt anyone. I'm okay with that. Well, yeah, that was like the first week or two of school. You just started blathering to yourself and all of a sudden it made sense. Okay? I just want y'all to do what works for you. Everyone learns a different way. Everyone can produce a different way. You don't have to do things a special way just because I said so. Everything to one side of the bus. Run down your perfect or your factoring decision tree. Is there a greatest common factor? Oh, we still in the tank? Still arguing?
Dividing by 3 times a 3 by 6. X equals 3 and x.
There was some distractions in there, and then I had to eat. So it wasn't
3
actually.
hours on your phone.
Okay, it looked like a few of us were still in the tank, so I didn't want to keep going. So,
I can get to there, but after that, I'm a little lost. And Eli's not helping.
I just didn't mean to not.
okay, that's exactly where I'm at right there, so I'm actually just going to go up there, because that's the exact spot I'm at. Okay? Once I'm here, you cut it in half, and you ask, what do they have in common? What do they have in common? These two got a 3x in common, leaving not a 3x, a 4x. Leaving a x minus 3. Be careful with the second pair. You'd say, well, they don't have anything in common, so I just put a 1 as a placeholder. But if I do, I have x minus 3 and a negative x plus 3. I have to take out the negative 1 to make the signs work. Okay? If I don't change that sign by factoring out a negative 1, this isn't going to work for me. Now that I see they both have an x minus 3, I factor the x minus 3 out. And when I do, I have a 4x minus 1 left over. Now I'm still not out of the woods yet. I have to finish. X minus 3 equal to 0. 4x minus 1 equal to 0. X equals 3 and 1/4. Now we're going to get to the point pretty quick where kids just recognize whenever you have a ax plus b form like this, it's just negative b over a, right? Because I'll have to change the sign, so it's positive 1, and then I'll have to divide by 4. So if I had that as a factor, add the 25, divide by 6, 25/6. If you can jump straight to that, great. I'm not going to make you write out this part. If you can't, then still write it. Because that skill is going to be important because we might get to something like that in another month. Okay? So we need to know how to do quadratics now when they're familiar. Oh, yeah. Okay, so preview of things to come. All right. Problem 3 says solving by graphing. Ruh-roh. Who remembers how to graph these? Oh, God, it's been a week. Since this is what half of you do on your homework anyway, let's get a decent sketch of a graph here. It ain't the best. In order to graph, I need to have it equal to y, right? So subtract 15 and get y is 2x squared plus 7x minus 15. Find your vertex. Negative b over 2a. B is 7. A is 2. Getting negative 7/4. Ew. Plug in a negative 7/4. Find that vertex. Oh, negative. Getting 49/16, 49/8 minus 14/4 is 28/8. So 49/8 minus 28/8 is 21/8 minus 15/8. So if I have 120, 29/8 minus 120/8. Negative 91/8. My mental mojo ain't here today. What'd you get? Oh, I went in the wrong direction. Okay. If I had to learn nonverbal communication like tone indicating a question the hard way, I think you can give me a break on that one. Now, this is going to suck, right?
Yes.
Like -7/4, negative whatever, and then I have to have a scale of 2 all the way up until it hits the x-axis, right? That's going to be a pain. What if I can't draw very well? What if I'm not using graph paper? What if I'm not using graph paper and I can't even tell where it hits the x-axis now because my graph is absolute trash? Shade at half of class. Can I find where it hits the x-axis somewhere else besides my paper? Yep. Get it. Go over to y equals, clear that out, 2x squared plus 7x plus minus 5, minus 15. Okay. All right. Type it in. Now, we were all monkeying with our calculators the other day. Plus, I think it was yesterday, pre-calc did some hardcore regression on ours. So, everyone do Zoom 6. Option 6 goes to a standard 10 in every direction grid. Because I'm betting that's where my, yep, there they are. Who cares about the vertex? What am I trying to do? I'm trying to find the x-intercepts, the solutions. What's another word for the solutions? There you go. Look at your notes. The zeros. Second, right above traces, calculate. Ta-da! Calculate the zeros on your calculator. You can graph. You can graph and find where it hits the x-axis manually. Or set everything equal to 0, dump it into y1. Get the graph and say, I will find my zeros. Now, be careful. It's asking for a left boundary. I need my left boundary to be on the left side of one of my x-intercepts. I got to find them 2 different times. Where is Blinky right now? I don't even see him. He's way down here, right? So keep poke, 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 poke. Blinky? Blinky, where are you? Oh, there he comes. Okay. As long as it's on the left side, as long as it's on the right side, and I know that's going to sound counterintuitive because it looks like it's up and down, but it is on the left and the right. Well, that was easy. -5. Do it again. Second, calculate, find a 0. Now, I don't have to move Blinky around either. That looks like it's between between 1 and 2. So how about I just say between 1 and 2, there's a 0, tell me what it is. So when it says to solve by graphing, I can just jam it in my calculator and then say x is -5 and 3/2. Because I like fractions. 1.5 is 3/2. Okay? So when it says to solve by graphing, you can manually graph it, but you run into this possibility that graphing it is just going to be disgusting. So jam it in your calculator and let Blinky do the work for you. Okay. Now, if I remember right on the Casios, we've got a couple who got Casios. Isn't that just one of the options at the bottom, just like solution or 0? Like you just graph a thing and then one of the options is find the zeros? I think. Not 100% sure, but I thought that was a thing. So, say we get to the homework, and the homework says solve by graphing. Unless it says make a graph and solve, you can do it in your calculator. If it says make a graph then solve, okay, actually graph it on your paper. But if it just says solve by graphing, you are welcome to use the calculator. See you do it again. All right, Casios aren't working with us. I could swear it was one of those bottom row options though. Okay. All right.
Okay, it looks the same, and then I clicked like turn off. Okay, let me give some boost. Which
Oh, but look at the scale. It's going all the way up to, like, the scale is just gigantic. How do you zoom in?
I don't like you can press the in button.
Why is it defaulting to such a huge window? Okay.
But still, it didn't look anything like yours.
It's still the same graph. It's just the window is so mucked up. Okay. So, menu. Okay, so you're just on regular graph. You did the thing. Okay. Draw, shift, view window. There we go. Okay, so shift and then view window. I'm betting standard is going to be that 10 by 10. There we go. Now, how do I go back? I just click exit? Okay.
Okay.
But where's the trace? Solve? There we go, roots. Second graph solve. Find the roots. Yes, it does. Okay, we just have to figure out how to use them, right? Okay. All right, Brooke, we got it. We found it.
I'm using this one now.
Oh.
On the transfer.
Okay. So exit, exit. Okay, so you got the original, right?
Yeah.
And when you go to draw it, it was the window's ridiculous.
Yeah.
Check this out. View window. So second view window. Standard. That's 10 in every direction, just like the one we just did.
Okay.
So we'll do standard. Then exit and go draw it.
Will it stay standard, or will I have to do that manually every time?
I have no idea. I think this one just keeps the last window you used.
Okay.
I'm pretty sure that's why the window was so mucked up,
Yeah.
is because the last time you used this, we were doing the regression models, and they were gigantic. So now, if you want to solve something,
Probably second.
graph solve
Yeah, I got there. I just
the
didn't know
root,
it's just the root.
and then it's just going to tell you, there they are. I don't know why it's not saying it though.
Maybe
Hers said, hers just said it on the bottom. I don't know why yours isn't.
Cause it's like on there, but why isn't it like popping up?
Huh.
Well, I figured it out on this one. So
What about second trace? No. 5.
Wait, that was it. The 5.
Well, I just put in a 5 for a trace value. Why aren't you y-intercept, intersection, root? So it's going there, it's just not saying it. Hers isn't that much different than yours. Why? I feel like hers isn't showing the root at all at the bottom. Like it goes there, it's just not saying anything. And I don't know what to do with that.
That's weird. I think
Here I was all excited because we had it figured out. And All right, so that's -6 and 4. Right? Is there anyone who's having trouble with the calculator to get that done? Okay.
So I texted in and I used parentheses because it wasn't working at first, and I changed my window, and then I was getting that.
Zoom standard.
The standard view, yeah, the lines are like there and there.
Okay, so something's up with our equation. X squared plus 2x minus 24.
Should I write a comment? What do you do? Was limited voice.
What did I do wrong? Maybe I did -24 instead of -24. Would that change it? I was.
Oh, yeah. If you type the negative button instead of minus, it'll take that 2x times a -24.
Oh, I see. Okay.
There we go. Then don't play cars on your phone. Ask a question. How's that working out for you? Mm-hmm. Oh, I'm sorry. Mm-hmm. You don't even have when the calculator's out.
I don't know how to use this.
Well, you're not going to learn by not doing it. Grab a calculator. Grab a calculator. You don't learn it by avoiding it. Come on now. I'm going to show you what buttons to press. What's up?
What is the thing between the -6 and the 4?
Oh, you remember doing intersection of sets, like with Venn diagrams? You'd say what's in the middle here was A intersect B. Everything that's in A or B was A union B. Okay, you saw it a long time ago. Intersect and union have mathematical operators and or.
Okay.
I just do that because I'm lazy and I don't want to put the ampersand thing. Okay? Yeah, you can do that too.
I didn't know. You think it's like a.
No, I got in that habit because of all the proofs that I did. So. Okay. I'm going to walk it through. You got a calculator. I have completely reset my calculator. I have a new calculator in front of me. I go to y equals. X's are right next to alpha. I hit x. It's x squared. Minus 2x or plus 2x? Plus 2x. You know what? Even better. Does it help if you actually see the key press or not? Like the last thing that I pressed. Some kids like it, some kids hate it. All right, so let's just say second plus enter 2. Clear. Okay. Y equals x squared plus 2x minus 24. I need to point this out because it happened again. Y'all, there's a difference between minus and negative. Okay? If I'm back here and I put a negative instead of minus, I want you to actually look at this. Okay, look at this when I switch it. It's smaller and it's a little bit higher up. If I do this, it's going to take 2x times a negative 24. I need to have minus instead. Okay, once I'm here, I would like them to graph my function. So I poke graph. Sometimes I can see all of the graphs, sometimes I can't. Sometimes I have to poke the window and change my x's and my y's. I want to know what these 2 points are. So I'm going to calculate. Everything up here does stuff with graph. I see calculate with my graph stuff. But it's in different colors, so I need to second calculate. And it gives me all these options. I can find this stuff on my calculator. I'm looking for zeros because that's literally what it asked me to do in the directions. So I'm going to calculate my zeros. Reading the card explains the card. If it asks for a left boundary, I need to put Blinky somewhere on the left of this 0. And then I'll put it somewhere on the right of this 0. I can manually do that. I can just keep poking Blinky here and say, Blinky, where are you? Oh, there you are. Okay. It's on the left. It asks for a right boundary. Move Blinky to the other side. As long as these 2 arrows are pointing in at the 0, I'm good. It's going to ask me for a guess. I say, no. Just tell me the answer. Okay? It's so you can guess and check. Like if you were estimating a problem, you can now put your estimate in there and say, I think it was this. So it'll show you how close you were. I'm just going to hit enter again and it'll tell me the answer. -6. So -6 is one of them. I got to do that process again to find the other one. So I'm going to calculate again. Second, calculate. I'm going to go find a 0 again. Except this time I want this guy. I don't have to keep hitting the arrows to move Blinky around. I can just tell it where to go. This looks like it's between 3 and 5. So left boundary, I'm just going to hit 3, enter. Right boundary, I'm going to hit 5, enter. As long as those arrows are pointing in, you're good. It's going to ask you for a guess, and we say, no. Just tell me the answer. Okay. Y'all knowing how to run the calculators is going to be very, very beneficial for you, especially, like you got 2 cases. Case number 1, you're coming up to college algebra or pre-calc. You need to know how to use these because we use them a lot. Option 2, algebra 2 is the end of the road for me. I'm done. I don't care anymore. I got my thing. I get in a 4-year college. I'm happy. Do you want to take an ACT? You can kind of cheat your way through about half of the ACT if you know how to use the calculator well enough. Like not even think, just press buttons. And these TI-84s are allowed on the ACT. In fact, I set it to pre-calc. I don't know if I told y'all or not. The math department has been talking about it. I used to do ACT test prep review for kids. No? I haven't said this yet? Okay. Back in the day, before the quarantines, before children, I would do a ACT test prep where I would have a group of like 6 kids who were going to be taking the ACT that Saturday. They would come in for like 2 nights. We would order pizza. They would all plop down here, and we would just jam math until like 7. And we'd do that for 2 nights, and we would just review stuff right before they did their ACT, particularly the geometry that you don't know. I was telling on our the day that you had off last week, I was telling the rest of them, I was thinking about starting this back up. They said, oh, hey, do you know we can get paid for that now through this TSI grant? We can all do it to spread out the pain, so it's not just one person doing it. Meaning the whole math department is looking at having ACT test prep sessions several times a year after school now, which is free instead of the rich kids get richer by having the test prep session that gets them a better score on their ACT, which gets them more scholarships because they had the money to do the thing in the first place. Generational wealth. No, we're going to do it for free. Like, come in, learn stuff. If y'all are interested in that, we need to know when the next test dates are. I think there's one at the end of October, if anyone is doing that one. Y'all are mostly sophomores, right? Okay, so you probably don't even care about this. You'll do it next year. All right, I was just wondering. Solving by factoring. We just did this, right? Wait a second. Whoa, 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 whoa. Back up, back up, back up. We just did solve by factoring. Why are we doing it again? Did we not read the directions? What does that say? Solve by tables. I want you to write down a note. If it ever says solve by table, don't. Because here's what they want you to do to solve by table. They want you to have your 5x squared plus 32x plus 12. Okay, I backed up to the first one we did. I just did it by factoring because I didn't even read the top of the page. The way that solving by tables works, you now go to your table. And I look back and I say, where's my zeros? Well, there's one of them, right? Where's the other one? It went from negative 15 to 12. What's in between negative 15 and 12? 0. So then I need to go to my table settings and say, start the table at negative 1. Now let's go by tenths. There it is. Now imagine when that's a really nasty fraction. So you narrow it to this space and then go by tenths. And then you narrow it to this space and go by hundredths. And then narrow it to this space and go by thousandths. That's why it sucks, and that's why you never do it. Solve by graphing or factor. Cool? Never do it by tables. It's lame. So let's back up to here. You notice that it says problem 1, and it's actually our third problem. If I was reading them, I would have noticed that. I know how to solve by factoring. Hey, get back here. Solve by factoring, I say x minus 2, x minus 3 is 0. I factor this. Factors of 6 add up to negative 5. I set them both equal to 0. Yay! I found my answers. Right? The difference is how ugly a factoring it is. Sometimes it's nice factoring like this, sometimes it's not. But you have to set them equal to 0 to make it work. Okay? That's way better than that table crap. I would rather do this every time. So, each of them has a little bit different flavor. They all have to be rearranged. Some of them have a greatest common factor. Some of them you do by AC method. Some of them are nice, easy ones. Take your pick. We did all the factoring stuff yesterday. Set each one of these equal to 0 and then factor. Start by putting everything on one side of the bus. Take out a greatest common factor if you see one. Everything to one side. Take out a greatest common factor if you see one. Yo.
Explain why the 12 there isn't negative. Aren't you subtracting from that side?
The 12 isn't negative. Oh! Harrison got me. He got me.
Oh, someone else has got
Yep.
He messed up twice. Wait a second. Yeah, there's two of them. So I'm saying we add the three, and then that's what I got.
One hand raised and another one shrieking in embarrassment. Sounds like we're settling an argument?
No, I don't know, maybe. So we're right here, and then to get the solution, do we just like ignore the thing we factored out? And write this equal to 0, and this equal to 0.
What has to be true? Don't look at that. Look at this. What has to be true? One of them's got to be 0, right? What still has to be true? Can this ever equal 0? So don't worry about it.
So we just leave it there?
You just leave it there.
Okay.
I'm starting to understand.
Now, I ask thee a question. Who is actually following that decision tree versus who just wasted a lot of time on part A? Greatest common factor. Check. Are A and C perfect squares? Yes. Is there a middle term?
Yes. Yes. I got that. It just took us
Can you do it with the AC method? Yeah. You're going to get 2x plus 3, 2x plus 3. But, y'all, we could have just gotten here. That works too. And then x minus 4, x minus 1. Same thing happened here. A minus 4. Okay.